This is assignment 3, shell fabrication, and we're going to be looking at 3 areas of shell fabrication: thermoforming, grinding, and posting. Our material for fabrication today is a 4 mil polypropylene that has been roughed on one side so the glue adheres. Our oven's been heated to 400 degrees for the polypropylene. It's placed directly above the vacuum form, and the casts are placed on the blocks inside the vacuum form. The plastic is then laid on top of a Teflon sheet, good side down, and we're going to be cooking it for 6 minutes, 3 minutes aside. In this particular oven, I'm going to be flipping the plastic halfway through just to ensure an even heating of both pieces. Once the plastic has been heated, we'll be taking it out and laying it on top of the cast, making sure it covers obviously the whole area of the cast to be formed. I'm using a pair of gloves to ensure that I don't get burned by the heat of the plastic. And then be closing the vacuum form lid and securing it, and then turning on the vacuum pump to remove all the air and vacuum form the polypropylene to the cast. Once all the air has been removed from the vacuum form, we'll be leaving the plastic to cool. Once the plastic is cooled to room temperature, it's safe to remove from the vacuum form. At this point in time, we want to evaluate how the plastic pulled to the cast. We want to make sure that there's a tight grip on the cast, that there's no air pockets in the plastic, that the plastic is a consistent thickness, and that it's captured all the positive cast modifications without any wrinkling of areas that aren't going to be removed. And once this process is done, I'm going to make sure the name is on both of the polypropylene negatives. This video here shows a bisection of the 1st and 5th metatarsal that's going to give us our width measurement for the shell. And here we want the medial width of the shell to be medial to the bisection of the 1st, and the lateral width to be lateral to a bisection of the 5th. And here I've drawn out the distal end of my shell. This line is approximately a centimeter behind my line marking out the met heads, and it also includes the bisection lines of the met heads so I can grind out the shell width. Here we want the anterior border to be 10 millimeters posterior to the 1st and 5 millimeters posterior to the 5th, and the curve of the metatarsals to match. And before grinding, we're going to ensure that we have adequate safety equipment, goggles and ear protection. And we're going to be removing the excess material using a bandsaw and doing a grinding on an S500 grinder. There's a 40 grit sandpaper, and there's a built-in dust collection system as well as an external dust collection system in this grinding room. For the sake of time, I'll only be showing the excess material being removed with the bandsaw on one side. So the first thing I'm going to be grinding is the distal shape of the orthotic, and I'm going to be grinding using my line that describes the arc of the metatarsal heads. Then I'm going to use my width measurement to get the appropriate width for a regular orthotic. Secondly, I'm going to grind a flat section underneath the metatarsal head so that the orthotic is balanced so it doesn't rock from side to side. I'll be grinding this as thin as possible so that the patient doesn't feel anything underneath the proximal metatarsal heads, and so that there'll be a smooth transition between the top cover without feeling the edge of the plastic. I'm then going to place the orthotic on a flat surface and make sure it doesn't tip or rock, because I'm looking for a balanced orthotic. I'm then going to grind the distal portion of the arch on both the medial and lateral sides just to create a smooth transition between the lateral and medial borders of the orthotic and where those borders taper off to nothing. And then I'm going to grind the heel of the orthotic using the flat section of the forefoot as a guide. I'm going to grind a flat section into the heel so that the heel is stable and so that the heel is also the desired thickness. I'll be making the heel of the orthotic as thin as possible so that we get the best fit inside a shoe. The two ways I'm going to test that are first off to push on the center of the portion of the plastic that I'm grinding. As the plastic becomes thin, it will also become flexible in the middle so that I don't blow through. You can also check thickness by holding the plastic up to a light. And as I'm not putting any extrinsic posting into the shell, I'm going to make sure on that flat surface that the forefoot and the rear foot are level and that the orthotic doesn't rock, that it's nice and stable, and that the rear foot and forefoot are in the same plane. I'm then going to grind the heel cup depth. Heel cup depths can range from 20 millimeters to 0 millimeters depending on the fit of the shoe. We'll be grinding a normal heel cup, which I'm looking for about 1 centimeter of depth. We have a line on our grinder marking 5, 10, and 20 millimeters, and my heel cup is at 10. I'm then going to grind the sidewalls of my orthotic from 0 at the metatarsal heads to the height of the heel cup. I'm going to make sure that the lateral and medial sidewalls have smooth transitions so that they look good and that they are the appropriate height to match the heel cup. And then I'm going to grind my 4 mil polypropylene sidewalls to a thickness of between 1 millimeter and 1.5 millimeters to make it fit in the shoe well, but also to give me a decent sidewall thickness. And I want to ensure that the thickness is uniform all the way around the sidewalls and the heel cup. I'm then going to use a smaller smooth wheel to do the interior bevel of my heel cup and sidewalls to ensure a smooth transition from the orthotic so that the patient doesn't feel any sharp or rough edges on the orthotic. I'm then going to put a sidewall bevel on my orthotic. I'm looking for a better shoe to shell interface, and I'm also going to do a plantar skive or bevel underneath the plantar surface of the orthotic, again to ensure a better fit in the shoe. I'll then be using a smooth wheel with a high grit sandpaper to do all the finishing touches on my orthotic. Any area that was ground with the rough 40 grit sandpaper of the main grinder should be smooth to ensure a professional finish on the orthotic. And lastly, I'm going to compare my orthotic shell to my cast and ensure that the width and the anterior border of the shell match. And as I grind my second orthotic, I'm going to make sure that heel cup depth and shell thickness and height, both laterally and medially, matches as much as the feet are similar. And when comparing my two orthotics, you'll see that the metatarsal lines, the thickness, and the length is the same. And to attach my EVA posting, I've drawn two lines across the hindfoot of both orthotic. These two lines are symmetrical, and then I'm going to use a rough wheel to roughen up the smooth plastic so that the contact cement and the EVA will adhere to the surface. The two functions of the rear foot post are to angle the shell in a desired direction or to stabilize the shell. This particular post is simply to increase the base of support and stabilize the rear foot. And the safety measures in place for gluing. We have an extractor fan built into a fume hood. We have our oven and our glue pot. I'm then going to glue the roughened areas of my polypropylene shell and allow the glue to cure before I attach the EVA. When the glue is cured, it should be not tacky and dry to the touch. I'll then be taking the EVA and placing it in an oven to heat form it to the shell. When the EVA has reached an adequate temperature and is soft, I'll remove it from the oven, and I'll then be attaching it to the hind foot of my orthotic and pressing it onto the plastic to ensure a good bond. And then we're going to remove the excess EVA from the shell using the grinder, using a similar method to grinding the polypropylene. And we want to make sure we maintain the shell posting angle. In this case, we want to maintain the relationship between the forefoot and the rear foot, which is posting to neutral. So the forefoot and the rear foot should be the same posting. And lastly, we want to make sure that the EVAs are symmetrical between the sides and that the heel height and the sidewall height is still the same. Ensuring that the sidewall bevel is similar so that the orthotics are going to fit similar in the shoes. And that's it. 2 orthotics fabricated, and you can see they are the same.